One of the most misunderstood electrical concepts in the 80% rule. Electricians sometimes size breakers incorrectly because they misunderstand continuous load calculations. Today we're going to break down how breaker sizing actually works and what the electrical code requires. Rules 14-104, overcurrent device size rating. Breakers protect conductors from overheating. Breakers are designed to protect the conductors, not the equipment connected to the circuit. 14 gauge on a 15 amp breaker, 12 gauge on a 20 amp breaker. If the breaker is oversized, wire may overheat before breaker trips. And again, you can refer to Rule 14-104, which I'm going to show on the screen. It also goes on to say rating of overcurrent devices, tells you to see Appendix B. The rating or setting of overcurrent devices shall not exceed the ampacity of the conductor that they protect, except A, where a fuse or circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available, and the minimum calculated or known load is in accordance with the rules of Section B. The ratings or settings given in Tables 13 shall be permitted to be used within the maximum value of 800 amps. In the case of equipment wire, flexible cord in size number 16, 18 and 20 gauge copper, and tensile cord which are considered protected by 15 amps or 20 amps overcurrent device, or C, as provided for by other rules of this code. Also goes on to say 2, except as provided for by sub-rule 1C, the rating or overcurrent protection shall not exceed 15 amps for number 14 gauge copper conductor, 20 amp for number 12 gauge copper conductor, 30 amps for number 10 gauge copper conductor, 15 amps for number 12 aluminum conductor, and 25 amps for number 12 aluminum conductor. So it also says to go to Appendix B. So if you head over to Appendix B, Appendix B simply says, Rule 14-104, when conductors are selected based on a calculated load or a known load, Table 13 is useful in selecting the appropriate rating of overcurrent device based on the installed ampacity of the conductor. For the installation code, users are reminded that the circuit loading requirements of Rule 8-104 apply. It is intended that the ampacity values used by Table 13 can refer to single or multi-conductors. Table 13 is also useful in determining standard overcurrent ratings for rules such as 14-212 or 26-254, number 3. So now we're going to go into segment 3, the 80% rule. Rule 8-104, maximum circuit loading. Continuous loads must be calculated at 125% of the load at all times, which results in 80% of the rule. For continuous load, a breaker should only be loaded to about 80% of its rating. Example, you have a 20 amp breaker times 80% equals 16 amps continuous load. Example, electric heater drawing 16 amps continuous. Rule 8-104, maximum circuit loading, tells you to go to Appendix B. Also says, 1. The ampere rating of your consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device, protecting the circuit, or the ampacity of the conductor, whichever is less. 2. The calculated load in the circuit shall not exceed the ampere rating of the circuit. Also goes on to say, 3. The calculated load in a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that its normal operation will not persist for a total of more than 1 hour in any 2-hour period if the load does not exceed 225 amps. 4a, a total of a cyclic or intermittent nature shall be classified as continuous unless it meets the requirements of Sub-Rule 3. 5. Where a fuse switch or circuit breaker is marked for continuous operation at 100% of the ampere rating of its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker. And A, except as required by item B, shall not exceed 100% of the ampacity of the conductor selected in accordance with section 4, or shall not exceed 85% of the ampacity of single conductors selected in accordance with section 4. Also goes on to say 6. Where a fuse switch or circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker. And A, except as required by item B, shall not exceed 80% of the ampacity of conductors selected in accordance with section 4, or shall not exceed 70% of the ampacity of the single conductor selected in accordance with section 4. The continuous load as determined from the calculated load connected to a cable bus shall not exceed the value specified in Sub-Rule 5 or 6. So 8-104 is sending us to Appendix B, and under the Appendix B, the rule states, Rules 8-104, 8-304, and 62-114. When an overcurrent device is located in an assembly such as a fuse switch or a panel board, the assembly is required to be marked by continuous operation of its overcurrent device in accordance with the requirements of CSA C222 number 4 or CSA C222 number 29. Rules 8-104, maximum circuit loading. This rule also explains how circuits must be sized for loads that operate for long periods of time. Continuous loads must be calculated at 125% of the load, which leads to the 80% rule for breakers. Example, 20 amp breaker times 80% equals 16 amp continuous load. Where the 3-hour definition comes from, the 3-hour definition is part of the continuous load definition used in electrical standard, and the NEC, and it is widely taught in electrical training. A continuous load is a load expected to operate for 3 hours or more. Rules we use are 8-104 for calculations. Under electrical code, continuous loads must be calculated differently because they operate for long periods of time. In practice, a continuous load is typically considered any load expected to run for 3 hours or more. Examples of continuous loads: electric heating, EV chargers, commercial lighting, industrial equipment, server rooms. 20 amp breaker, continuous load allowed. 20 amps times 80% equals 16 amps. Meaning, a load drawing 16 amps continuously is accepted on a 20 amp breaker. Continuous loads must be calculated at 125% of the load, which results in 80% rule for breaker sizing. Rules 8-104, maximum circuit loading. Rules 14-104, rating overcurrent devices. These two rules will support my explanation. Rules 14-104, rating of overcurrent devices, see Appendix B. The rating or setting of overcurrent devices shall not exceed the ampacity of the conductors that they protect, except a where a fuse or a circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available, and the maximum calculated or known load is in accordance with rules or of Section B. The ratings or settings given in Table 13 shall be permitted to be used within the maximum value of 800 amps. In the case of equipment wire, flexible cord in sizes number 15, 18, and 20 gauge copper and tensor cord, which are considered protected by 15 amps or 20 amps overcurrent device. So I'm going to run through Rules 8-204, which is on the schools. The calculated load for the service or feeder shall be based on the following. A basic load of 50 watts meter square of classroom average plus. B, 10 watts per meter square of the remaining area of the building based on the outside dimensions, plus electric space heating, air conditioner, and total loads of other permanently connected equipment based on the rating of the equipment installed, plus, except as permitted by Rule 8-106.10 or Rule 8-106.11. Any electric vehicle supply equipment loads with a demand factor of 100% plus. Cord connected equipment intended for connection to receptacles rating more than 125 volts or a 20 amp based on 80% of the rating of the receptacle or the rating of the equipment intended for connections in the receptacle to the receptacle. Demand factors shall be permitted to be applied as follows. A, for a building with an area up to and including 900 meters square based on the outside dimension, as permitted in Section 62 for any electric space heating loads provided for, and 75% for the balance of the load. And B, for a building with an area exceeding 900 meters square based on the outside dimensions, outside dimensions as permitted in section 62 for any electric space heating loads provided for, and the balance of the load shall be divided by the number of square meters to obtain a load per square meter rating, and the demand load may be considered to the sum of A, 75% of the load per square meters multiplied by 900, and B, 50% of the load per square meter multiplied by the area of the building in excess of 900 meters square. Also goes on to say 8-206 hospitals. The calculated load for the service or feeder shall be based on the following. So a lot of common mistakes that we see on the jobs, basically when it comes to breaker sizing and installing the correct breaker, is basically having a 15 amp breaker and having it protecting a 14 gauge wire, which is supposed to be, even though it's supposed to protect the 14 gauge wire, you have to pay attention to also the 80% rule. And what the 80% rule is, the number of devices that you do have on that circuit will determine how much load that you're going to push out. So in order to stay within your 80% rule, you have to kind of reduce the amount of devices that you're going to have on a circuit. 15 amp circuit, for instance, 15 amp circuit with 15 amp receptacles. A lot of times I will install about 7 per circuit. That gives the circuit enough to operate without overheating. Also, you have to keep in mind that when you are sizing your breakers, you can oversize your wire. So let's say, for instance, you're going to be wiring up 15 amp breaker, 15 amp breaker, 14 2 wire. You can upsize it to 12 2 wire. 12 2 wire can fit on a 15 amp breaker slot, so you can upsize it. You also have to pay attention when you do upsize if your wire will fit in the breaker itself also. So again, a lot of common mistakes you see on the job a lot of times will be oversizing, undersizing the wire run, and also upsizing the breaker when you're not supposed to. It could be very dangerous. A lot of times, if the circuit does overload, the breaker now is not protecting that circuit. And what the breaker is supposed to do is protect the circuit, protect the wire. And when you do overload the circuit, the breaker cannot do its job. So very important, overheating is real, and a lot of times people will take the wrong breaker, install it on the wrong size, wrong gauge wire, not knowing that it can cause a fire. So always remember, oversizing your cable for your run is better than undersizing and then having to install a bigger breaker that does not fit the job. It's a code violation. Also, specific rules inside of the OESC 2024 will tell you your breaker size per wire. There's a chart for it, so it will refer itself to it. It's in the back of the tables, so it is there, and it will tell you what you're supposed to wire up. So a lot of times that's where you're going to head to look for the specific rules and breaker size that you're going to be using. You also saw it is in, I believe it's 14-104, which is on the breakers. You'll see the sizing in that rule. Also, breakers against your wire size. So, like I said, a lot of times mistakes I see on the job, undersizing the wire, installing a bigger breaker that's not called for, that can simply overheat. Also, a lot of times wrong breaker instead of the panel. Pay attention to that, very important. So imagine a circuit supplying electric heater drawing 16 amps continuous on a 20 amp breaker. That's acceptable because it falls within the 80% rule. Breakers protect the conductors. Continuous load must follow the 80% rule, and proper breaker sizing ensures the wiring does not overheat. What breaker sizing mistake do electricians see most often on job sites? So thank you all for tuning in to today's video. And again, you can catch my live stream that's coming up on Wednesday at around 9 p.m. is going to be my live stream. So you can catch me on my live stream, live Q&A, and you can also, don't forget to check out the next video that's going to be coming up on the screen.